All right, everybody, welcome to class. This module, we're going to be working on unit tests and exception handling. The content we're doing right now is going to be exception handling, and then there's going to be another video for unit testing. This week, this material is going to be a little bit shorter than what we've been having in the past. So I'm just going to go grab the content. I'm going to go paste it up here in our Visual Studio Code. Get this bad boy running. Okay. And we'll start up here at the top. Okay. So I guess the first question is, what is an exception, since we're talking about it? You may have seen them already, and it's probably overdue time that we talk about them. But an exception is generally just anything that can go wrong in our program, and then maybe more specifically, things that can go wrong in our program that we're not really handling as programmers. There's ways that if something bad happens in our code, something we're not expecting, our program can terminate, mid-program. It won't execute all the lines of code. And if it does, that's because we have what's called an unhandled exception. And so basically, an exception is anything that can go wrong in our code, and they're typically going to be our fault. They're things that we should have known better, or we should have been prepared to handle, and we just weren't. So some examples of that are reading bad data. If the user is inputting data, they can type in something that we weren't expecting, like if we're trying to cast the user input to a number, and they give us a string. We can't do a casting from a string to a number, and so then it would give us some sort of exception. Or if a resource is not available, and that's probably the more common one. So say, for example, we're reading a CSV file, or we're connecting to a database, or we're calling some web service, or whatever the case may be. We're grabbing data for our application to use and to parse. And when we do that, there might be issues grabbing those resources. Either they may not exist, the file doesn't exist, or the file's locked, or file's in use. Or we may not have security rights to access, a database, or we're getting no data when we're trying to run queries, or whatever the case may be. So those are things that exist and are sort of outside of our program, and we need to be able to handle those. And when they do come up, it's going to be known as an exception, right? So we need to make sure we're looking out for those sorts of things happening, and that when we do, we try to handle them gracefully. So I wanted to show you a couple examples. I just wanted to show you what an exception looks like, just so we're all on the same page about it. So that's what we're going to do here in this section. But again, it's our job as programmers to prevent these things from happening. That's our job. We need our application to be resilient and robust, right? So instead of crashing, like we're going to see here in a second, we need to be able to gracefully handle that. We want to present some sort of message to the user and give them a chance to fix it. Right, so in the case of like the file not found error, right? If we're trying to read file from a CSV file, data out of that, and the file just doesn't exist, instead of crashing our program, we would say something like file not found, please select a different file. And that way our program can continue to run. And if we don't handle that, we get these unhandled exceptions, which just cause our whole application just to stop doing what it's doing. So let's see what that looks like, just so you and I are on the same page about it. Oh, looks like I got some bad code a little bit further down. Yeah. So let me fix that really quick. Trying not to give away too much of the code before we get there. I'll fix that and change it here in a second. Okay, so let's try this again. So let's save it and run it. Okay. So a really common, or a really easy error, I should say, to reproduce is a divide by zero error. So anytime you're doing math, you want to make sure that if you're doing division, that you do some sort of check, that you're not dividing by zero, Because if you do that, you get something like this. It says an exception has occurred, a zero division error, division by zero, and then it tells you the file and the line and all that stuff. And then the code won't keep running, right? It won't jump down here to the next one. The whole program just terminates and stops. And then what the user sees, we saw that red box, right? That thing that came up, but what the user is going to see is this on the screen. They run this program and they see this big old thing. And that's not very helpful or friendly to them. It just, they're like, oh, on line 18, it's dividing by zero, assuming they can piece out, you know, the bits that matter, right? Because you got to ignore these first 4 or 5 lines. So this isn't very friendly to the users. It's not very friendly to our program, right? So we just need to have a systematic way of handling these sorts of things. I can show you a couple other examples here. So this one is where we're grabbing input from a user. It's going to be down here, right? So we're saying, give me a number. If I enter a number, it's fine. But if I enter like a letter, again, we're going to get another exception, right? A value error saying we're trying to convert the string that you gave me into an integer, but you can't convert the letter P into an integer. And so it says, I don't know what to do anymore. So the program just stops. And again, the user is going to get this big old monster of a thing. Can't even see it all. It's there right here. So it's going to get all this thing right here. Okay, so we don't want to show that stuff to the user. All of that stuff right there. We want to handle these exceptions. We want to show them nice, friendly things and give them a chance to fix the problem. And I'm just going to comment these out so we can continue on further down. Similar thing, again, I'm just trying to show you a few exceptions and what they look like. This is a different one, saying an index error. This is when we have an array or a list or a tuple or a dictionary or whatever we're using, and we try to access data that's not there, right? So we have in this list here, on the first item, we have the number 1. On the second item, we have number 2. The third item, we have number 3. Right? But now we're trying to grab the 4th item, and it says there is no 4th item for you to grab. And so this is an index error or an out of range error. So it's saying I can't go grab a 4th item. There's no such thing in that range of data there. Okay? And again, that's just going to cause our whole program to stop. It doesn't keep going, and we show this really gross message to the user. Okay? And then one more. Trying to open a file. We haven't worked with files yet. It's going to come up in the next week or two, so don't worry about any of the syntax. I just wanted to show you that I talked about it a second ago. Looking for a file, and it may not exist, like in this case. I don't have a file called chat.txt, and it can't find it, so it says file not found error. It says it doesn't know what I'm talking about, how to find it. And when the program doesn't know what to do anymore, he just stops. He can't keep going. Okay. So again, this is the sort of error message that we get and we're showing to the user, and it's not very friendly. So let me comment this out. Okay. All right, so all those things we saw in red for us were exceptions. We get those gross things at the bottom, and they're almost always going to be our fault as programmers. I mean, we may not be the ones who put in the bad data, but it's our job to anticipate what could go wrong and to handle it ahead of time. You know, we want to be proactive about this stuff. And so that's our job as programmers. And if it happens, then we didn't do our job. And like I said before, when your program is executing for the other end users, it's not going to be in this debug mode or in VS Code like we're seeing. It's going to be more like this down here, where they just type in the program name to run it, and it does its thing and outputs the result. But all they're going to see is some gross message like this, so they're not going to know what that means or what to do about it. And there's no chance to fix it. So we need to make sure we handle that. Okay. So we have a couple of strategies that we can do for handling exceptions. The first one, and the most obvious and easiest one, is to put some logic checking in our code. For example, on the divide by zero error up here, I could have put an if condition up here that's checked, you know, to make sure that whatever number we're dividing by is not a 0. And that could have avoided the whole error if I had done a little if check. Likewise right here, I'm trying to cast it to an integer, but I could have done a check above here saying, oh, make sure that they didn't give me a letter. Make sure they actually gave me a number, and then I can try to cast it to an integer, right? And likewise right here, I could have done another if condition saying, go find the length of this array and make sure there's actually enough data to go do what it's doing, right? And likewise, I could have gone and checked for the file a different way. So I could have done some checks and some smarts on our side. That's the easiest way to handle these exceptions. Just to think about what could go wrong, preemptively sort of put in these checks that says, are these certain cases or conditions going to happen? And if not, then we run that code. And if that exception might happen, then we just send some message to the user saying, I can't let you divide by 0. Give me another number. Or I can't convert the number p into a number, so type in something different. Right? We could have done all that. But that's not what we're going to talk about today. We're going to talk about the more formalized way we have and the more expensive way we have. This takes a lot more processing time to do exception handling like we're going to be talking about here. But the whole idea here is we want to come up with code that we think might be problematic. And then we're going to wrap it up in a try block. And a try block is just kind of like you've seen with the ifs or the fors, where we have this line right here like we do on 56. And then we have the colon here at the end. And then we put whatever code might have issues, right? So we're saying try this code, whatever is underneath that, whatever's indented underneath the try. We're saying try this, see if it goes okay. If it goes okay, no big deal. The code will run. But if it has an issue, then we have sort of this formal structure that will allow us to handle it. Okay? So for example, I took the same code from up above, these things here that I've already commented out, and I just wrapped them all in try blocks to show you what they could look like here. So the divide by 0 error, I'm just trying, I say go try this bit of code. And if you have an issue, we're looking for specific exceptions that can happen to this data. So I'm saying try that, and if you get an exception that is a zero division error, trying to do that line of code, then we're going to do something about it, right? And in this case, we're just going to print out a message saying that your denominator cannot be 0. So let's put a breakpoint here. Let's run this code. Let's see what happens. Okay, so we're here. We know this is going to cause an issue because it did up above before. But now you can see our yellow control cursor here said, oh no, I found an exception. And the exception I got is a divide by 0 error. You can see right here. And then we're just going to put a little message out to the screen right here. Your denominator cannot be 0. And now our program can continue on, right? You can see now it didn't stop the whole program. It's going on to the next one. This little yellow focus of the control. Okay, so now we're doing something else. We're saying, and again, this was just all the same code up here above. So this time we're asking the user for a value. I want them to give me a number. I'm going to type in something purposefully bad. I'm going to type in a P. And again, it's going to try to do it. It's going to say, can I cast the data that the user gave me into an integer? And turns out, no, we can't. We tried it. It failed. We're looking for a specific exception. In this case, we're looking for a value error. And then it's going to just put out a message saying, you need to enter in a number, right? Instead of the letter or character like we did before. And again, we handled it. Our program continues running. It doesn't stop. And likewise, or typically what you would do is if you got something like this, maybe you want to have this whole thing wrapped up in a loop, right? Like in a while loop or a for loop or something. And you would just have the loop end and come back up and ask the user for different input again and keep looping until you get valid input or something like that. That might be a strategy you could do. Okay. And then here's the list one where we're trying to grab data out of bounds. And sure enough, we did. Okay, and then finally the file not found error. And then again, we couldn't find it, so all he does is he just prints out a message saying file not found. So I wanted to show you a couple of things here, right? So we find the code that we think would be problematic. We put a try clause around it. We surround it in a try clause. And when we do a try clause, we need to have some sort of exceptions that we're trying to look for. In this case, I knew what these issues were going to be. I knew there was going to be a divide by zero error. I knew there was going to be a value error. I knew there was going to be a file not found error. But sometimes we don't know what the exception is going to be. We just know that it might be problematic. And if we don't know what specific type of exception is going to happen, we can just use the general word exception. We're just going to catch pretty much all exceptions is what that's saying. And so I can't be more specific. I don't know what went wrong here, but I know something went wrong. And that's pretty much all we're doing with this case right here on line 72, I should say. Okay. Hopefully this is starting to make sense. It's a lot more, not a lot more, it's a little bit more code. And we have to think about things a little bit differently. We want to sort of think preemptively and figure out how we're going to handle letting the user fix the problem, but it's not going to crush our program, and that's the idea. Okay, so with this code here, we try to run all the lines of code here, and then anytime there's this specific error, it's going to execute whatever code is in there. But we also have the option of not just executing code when an exception happens, like we're doing here. We also have the option of executing code when there's no exception, when there's success. So this is the slightly different use case here. So we have the try. We're asking the user for a number. They're going to type in something that's either good or bad. And then we're going to either, if there's an error, we're going to do this, or if it succeeds, we're going to do this. And so all we got to do is we do the try and accept. Those things are required. And then we do the else, which is an optional thing we can add on there. This isn't necessary. You can see we didn't do it up here. We can add it optionally. And anything in this block of code indented under the else is what we'll execute if it was successful. So let me comment out these things up here and show you. Doing some commenting. If you're wondering how I'm getting those comments to come up like that, you select the text you want to comment and you hit Control / or the Control ? Key. That's the mass comment quick key. Okay, so now we're going to ask the user to give us a number. And again, we're going to type in a P if it's bad or bad. And you can see the yellow control, the focus has gone here. It's saying, you didn't give me a number, so please enter it. It did not go here. It skipped over that section. And now let me run it with something good in there. So it's asking him for a number down here. This time I'll give it a number. We'll give it the number 2. And it's able to successfully convert this to a number. And now it jumps down here to the else statement. And it skipped over the block of code you would do for an exception. Hopefully that illustrates what I'm talking about here. It makes some sense for you. Okay. On these examples up here, all we did was we said catch these exceptions of this type and to do something. When we're catching exceptions, we have the option to store the exception data into a variable. So the only difference here is I use this keyword as, and we give it some variable name. I could have called it whatever. I called it EX. I could have called it whatever I wanted. Doesn't really matter. We're going to just call it EX because that's what I already have down here. Okay. So all this does, now that we can use this special or this extra keyword of as, and you give it a variable name, anytime this exception happens, it's going to store all the details in this variable. And then we can use that variable here within our block in case we need to do anything about it. And that comes in useful for things like if you want to do error logging, that's a really common thing. Developers and testers want to know how long things are taking, what sort of issues are happening in the system, any sort of failures, and they log those to files behind the scenes for themselves to look at, or the user can, send those off to the company and get some support and stuff like that. So it's a pretty common thing to do. So let's try this and see what happens. Oops, I did not put a breakpoint. Let's try that again. Okay, it's asking us for a number. We're going to give it something that's not. Okay, we came here. And now when we hover over this EX, this are all the things that it knows and gives us. So basically it just says the message, and that's about it. And then we can do something with that, like print it to the screen, log it, whatever. And in this case, I was just showing you, here's the message that you get. And then this is the type of exception. It is a value error, and that's what we're catching here is a value error. Okay, so we have that option to do that. Okay. So we've talked about what kind of errors you could catch, but I wanted to show you a slightly different scenario, which may or may not be interesting. So here's a slightly different line of code. The only thing we did here is we're trying to figure out how many decades old this person is. I think I may have the numbers backwards actually. But I'm trying to illustrate a divide by zero error and also a value error. So we have two different things that could go wrong here. For example, if I type in a P, I'm going to get this value error. If I type in a 0, I'm going to get a divide by 0 error. Okay, so there's two different exceptions that could happen here depending on what sort of input the user gives us. So let's see what happens here. Okay, so say give me a number. I'm going to type in a letter, and it's going to say I can't handle that. And just like we saw before, it comes over here, throws a value error exception, right there, and then we go along our way. But what happens if I type in a 0? 0 is a number, and it can do that, right? So it casts it into a number, and that's fine. But I can't divide by a number, a 0, I should say. And so what happens here is it throws us an exception, a 0 divide error, because even though our code is wrapped in a try block like this, we're wrapped in a try block, so we think that there might be problematic, or it could be. We're only catching one possible exception, which was the value error, which is the converting or the casting right here. We do not also have a divide by 0 exception here. There we go. So I wanted to show that. So we would have to tweak this code. So let's comment this out. We would have to tweak this code. So it's the exact same code. The only difference is I added this in here. So you can handle or catch, is the right word. You can catch or handle multiple exceptions by just duplicating this block of code. And you can do different things, right, for each of them. So now we're saying catch value errors and do this, catch divide by 0 errors and do that. And if there's no errors at all, do this. So we got quite a bit of stuff going on here, a lot more weight and things going on than what we would have just had with these 2 lines of code. And that's because we're trying to make our program more robust and to handle, the unpredictable user. Okay. I'm going to comment that out. That should make sense right there. The other thing we can do, you can see right here, we have a value error and a divide by 0 error. And it could be that for whatever these errors are, we don't want to do different things. Maybe we just want to log the error and just tell the user a generic message like, a problem in the program, please contact support or something like that, or enter in proper data or something. If we want to do the same sort of thing for lots of exceptions or multiple exceptions, we can change our exception block to do this. And the only difference here is we put it in parentheses and we separated them by commas. So we're just saying anytime you get a value error and a divide by zero error, do this. So that we just put multiple there. That we don't need to repeat our except block lots of times. I did want to point out something here that might be interesting to you. It's definitely something that you'll need to know as a programmer is you can see we're handling the divide by zero error in two places. Okay, so I want to run this code and we'll see what happens. I'm handling two places and I just want to, I don't know, just make it obvious what we're doing here. So we're asking for a number. I'm going to type in a 0 because that's the thing we're doing twice. We're handling zero division errors in two locations and doing two different things. Okay, so we're going to try to do that. That should be fine. And now we're going to try to divide by 0. That's not going to be fine. And you can see the yellow control focus went to here. I went to the very first one. And this isn't the right message, right? We did enter a number. We entered 0. We kind of wanted this sort of thing. And so what I'm trying to point out here with this chunk of code is the very first exception block that it finds that matches is the one it's going to execute. Kind of like the else if or the elif. How when you use an if and an elif, they're mutually exclusive. It's going to do one or the other. It's not going to do all of them. And that's what's happening here. These exceptions are mutually exclusive, and it's just going to go down the list until it finds one that matches. So generally how you want to organize your exceptions is you want to catch the very most specific things first at the top of the list. And then as you work down your exceptions, you want to put the more general and broad ones at the bottom to catch, you know, sort of the stragglers or the other things that you're not being accounted for. So it might look something like this. We're saying go grab and do something for these very specific things, and then this will just catch pretty much anything else that we're not accounting for down here. So the order of your exception blocks matters is the whole point here. So you put this, the more specific things up top, and then the less specific things at the bottom. I jumped ahead a little bit. Yep, that's what we said. Okay, so we're winding down here. We just got a couple more things to talk about. There's something else we can do with our try block. Let me scroll down here. It's really common to need to clean up resources. And what we mean by cleaning up resources is there's things outside of the control of our system that we don't have control of, and that we need to let go of when we're done so that other systems or other programs can use it. So examples of that are if we're reading a CSV file, anytime we open that file, the system puts a lock on it so nobody else can use it. And if we don't release that, that file is going to be locked forever, and then nobody can use it, including us, later on down the road if our program fails or doesn't clean up that resource. Similarly, like if you're trying to read data from a database, there can be things with not freeing that up, and then too many threads get used up on the database, which stops its performance. And so we want to release our control over the database, things of this nature. Or if you just have a lot of stuff in memory, you might be reading through like, a million different patients in the medical record, and you've sucked up, megs or gigs of memory. You might want to get rid of it, clean it up and throw it into the garbage, for example. And so these are ideas of cleaning up resources. And it comes in especially when we're talking about try blocks. Anytime we have code that's problematic, maybe we can only partially complete our operation. It's important for us to clean those up and to finish the operation. For example, if we're opening up a file and that works, and then we start reading or writing data to the file and that works, but then we get to some bad piece of data that just blows up our whole program. So now we've got the file open, we're midway through reading or writing the file, and then an exception happens. Now that file is left in limbo, right? We didn't have a chance to finish our processes, and the whole program just stops. And now that file's locked forever. So the whole idea is here, we want to be able to clean up these resources regardless of whether we had an error or it succeeded or whatever the case may be. We want a bit of code that's going to execute no matter what, right? So the except block, the code in the try block is going to do its best. It may work, it may not. But if there is an issue, only the code in the except block gets ran. And if there's no exceptions, then the stuff here is going to get ran in the else block. But there's one final block that we can talk about, which is the finally block. And the finally block allows you to put code in here that's going to get executed no matter what. Code here is going to get ran whether there was an exception, whether it was successful, whether this try block worked or not. It doesn't matter. This is always going to get executed. So now we've got the try, we've got the except, we've got the else, and we've got a finally. So we've got 4 different layers here, and you can have these excepts repeating as many times as you want. So it can get quite convoluted and lengthy, but just know that these, and here I can just write this out. So this is always going to get executed. This is only executed if there were no errors. And then these only executed if there is an error. Right, so do you see the difference here? So if we try to do this up here, right, we've opened up a file, we get some sort of issue reading it. We want to be able to close the file no matter what, so that it's not locked and held up by anybody else. And so we need the finally block, because if it gets through and executes without an error, that's good. That means it would come here. Because the alternative here is we would have to do something like this. We'd have to put it in lots of different places to make sure it was always ran. And that's not good, right? Again, from remember past videos, anytime we find ourselves repeating code, we're generally doing something wrong. And that's what the finally block was for, right? So we don't have to have that code duplicated just like that. Okay? I'm going to comment this out. There we go. I want to make sure I didn't miss anything. Okay, so that's the finally block. And that helps us to clean up our resources. We can put stuff in the finally block like closing the file or closing the database or getting things out of memory that took up a lot of space or whatever that we were doing. So that's the idea with the finally. And now we're going to talk about raising exceptions. So all this time we've talked about handling exceptions. What do we do when an exception occurs? We talked about methods last week, and we're going to be talking about classes and object-oriented principles in the weeks to come. And one of the things that's going to be really useful for us in just a generally standard sort of practice that we do as developers is we want to raise exceptions, meaning we're going to do operations that we think we can do in our methods. But if an issue goes wrong with it, we would raise the exception. And then that way, whoever's calling that method has a chance to do something about it, right? So you got to think back to our methods class for that to make sense. I got some code examples down here though. Okay, so here's just a base example, right? So let's say we're trying to calculate how many decades old a patient is. And again, I realize my math is not perfect here. Probably should have been the number divided by 10, but I'm trying to raise some issues here. So we could possibly have a divide by 0 issue, right? So we created this method with the def, the def statement, the define. We're calling it calculate decades. We pass in how many years old the patient is, and then all it does is return whatever the result is, right? And then here we're calling the method. We're saying calculate decades for a 25-year-old person, and it should come back with like 2.5 or something. And again, my math is wrong, I know that. Okay, so that's the idea. So now something can go wrong, right? We see we can get a divide by 0 error pretty easily. We also probably don't want negative numbers because people aren't usually going to have a negative number. They're only going to be positive, although I know it's not strictly true. There's gestational age and stuff in the NICUs we deal with. But for the most part, they're going to be positive numbers and they're not going to be 0. Okay, and so we can write our code like this, and we can just hope that the users don't do anything dorky. But as programmers, we want to make our code robust. We want to check for these sorts of things. So here's a couple of options we have we're going to go through. The first thing we could do is just try it. Say, wrap it in try, saying, all right, do this thing. See if it works. And if it doesn't, just return nothing, right? We're just going to return none, which is what'll let the caller know that we couldn't figure it out. That's something we could do. It's not the greatest. We don't want to hide these sorts of things from the caller, meaning right here. We don't want to hide it from whoever's calling our method. We want to sort of expose what's happening to it. The other thing we can do is instead of putting the try block here in the method, we could just put it around the caller, right? So we keep the method how it is. The method does its thing. And if there's any sort of issue, we've wrapped the call to the method. And then we can handle that here. So this is a little bit different. We moved where we're doing the exception handling. So these are all about strategies, right? There's not necessarily a right way or wrong way. There's just consequences to these choices that we were making. For example, if we chose this route where we just wrap our calls to that method with try blocks, that's fine. But what do you suppose would happen if we needed to call this method 20 different times from our application? Then that means 20 times in our code, later on down, we're going to have to put these try blocks around it each and every time. So that's not going to be very efficient, right? We don't want to have all these try blocks around every call to that method, 20 different times. That's a lot of wasted and duplicated code. It makes more sense to put it here in the method just the once, and then it's just being handled all the time no matter what. Or the third way we can do, and probably the better way, definitely the better way, is we raise an exception. So we check in our method, we say they're going to give us some input. We're just going to check that input before we do anything, saying, did you give me a number that's 0 or negative? And then we're going to raise. So this is a new keyword we're seeing. We're going to raise, and then we got to pick what kind of exception or error we want to raise. Okay. So we're saying raise a value error, and then we can give it a string of whatever custom message we want. And we're just saying that the age can't be 0 or less, right? So it has to be a positive number. And once we've raised it, then this line of code will never be hit, right? We're doing the check. If the check turns out to be a negative number or 0, it's going to throw this exception. And as soon as we throw that exception, control will not continue down here to line 292. Instead, it'll come out here to this try block, right? Because we're trying to catch and handle that. So let me run that just to show you. Get rid of some of these, some of those. I think last one here. Okay. So we're going to get rid of some of those. And now we're going to show you what it looks like when we raise an exception. So now we write our methods, and we're just proactively looking for scenarios that could happen and that we want to avoid. And if something's going to come up that we think we shouldn't be able to do, we just raise the exception, right? So pretty straightforward, hopefully. So let me just put a breakpoint here in a couple places. And we'll run that code. Okay, so we start out by calling calculate decades. This is the 4th version. I got a 4 on it. We're going to pass in the number 25. You can see it's passed in there. Now we're just checking. Is our age of years less than or equal to 0? No, it's not. So we're just going to go ahead and do the actual math, whatever it is. Hunky-dory. Now what do we do if it's like that? Or -1 just for some differences here. Now let's run the code. Okay, we get decades, we're putting a negative age. We're checking here, it's saying we're in a condition that's probably not very good. And we're going to raise the exception, right? So we say raise this value exception with this message. And as soon as we do, you can see it's not going to come down here to line 292. Instead, it realized right away I can't continue on doing any of that stuff, but I'm going to raise that exception to whoever called me, right, which is down here, and they see if they have a chance to fix it or do anything with it. So control jumps down here. We were catching value errors. I look here at my exception, and it says age cannot be 0 or less, right? Easy. Right. So that's a type error. Hang on. I just need to do that just to show you again. So let's run it. Okay. So now put it out here. Age cannot be 0 or less. Okay. So hopefully it's a pretty small topic. There's not like a ton of depth or detail to it like there was with some of the other stuff. It's just a matter of knowing the keywords, you know, the try, the except, the finally, the raise, the as, the else. And then generally how you're supposed to use them, right? And what scenarios you would use them. And one of the main tenets here, a couple of things more to talk about, is you want to only put the line of code that could be problematic in the try block. You don't want to put tons of code here. You don't want to have like 50 lines of code in a try. You want to have all the normal code doing its thing and only the problematic line of code or 2 lines of code in the try block. There's a lot of reasons for that. First of all, the try blocks are really expensive on our resources on our system compared to just running the code, so we don't want to have it do more than we need. Number 2, though, is if you have a lot of different lines of code in here, a lot of different errors can happen, and you won't be able to handle them all in the proper way. You want to be very like laser focused, like with the scalpel saying, I'm only looking for divide by 0 errors, and that's only going to be this code. You don't want to have 15 lines of code where 15 different exceptions can happen, because then you won't necessarily know what to do or how to handle it in each specific case. The other thing I wanted to show you was, excuse me, that's my phone. I wanted to show you was that this is the list of exceptions. We were talking about value type and divide by 0 and file not found stuff, but there's actually a full list of them. That's the link to it. So this is talking more about how to raise exceptions, but these are the exceptions. I'm going to scroll all the way to the bottom. You can see here, it's going to talk about them in detail. But the thing I find really interesting is if you roll to the bottom, there we go. So this one shows a hierarchy. Yeah, the hierarchy of the exceptions and how they relate to one another. And this is more interesting. It can help you find what you're looking for quicker than reading those narratives above. So we would just say all these exceptions inherit or are related to this base exception, which is what I was catching earlier. But then we have more specific ones, right? We have arithmetic errors, and here's 3 different specific types. Like this is one we saw, right? Division, 0 division error. That's a type of arithmetic error. I could have caught that, which would have caught those 3 types, right? And so these are all the errors that it knows about. You can create your own custom errors and exceptions. I'm not going to talk about that here in this class. It's a lot more advanced than anything we're going to need to do. And we have to learn about classes and objects first, which we haven't yet. So I'm just going to ignore that whole thing. Here's the file not found error that I was also catching. But there's a lot of different things we can handle. And so if you're looking for them, these are the specific lists of things. And then you find the one you're looking for, you can come up here and read more details about them. Right, like the file not found error says it's raised when a file directory is requested but doesn't exist. Blah, blah, blah. So that's where you can go to get more information. Or you can just Google Python, whatever version, Python 3, built-in exceptions. These are the built-in exceptions. Usually, again, you can create your own. Hopefully this makes sense. The assignment will help you have a chance to practice some of these things, as will the quiz. But if it's not making sense, try it and play around with it. That's how programmers learn things, is they just get their hands dirty and see what happens. And then if that still doesn't make sense, then just shoot me an email, or you're welcome to talk to the TA or whatever you prefer. Not a big deal.